I'm going to pick up where I left off in my last video. I was trying to find the surface area of the larger similar prism that I had here. Notice there's the problem, so if you really need to, you can pause it and read it again, but it's the same one from before. And I had left off where I was trying to find x in this case, which would be the length of that little piece right there. And once I figured that out, I'd be able to get the perimeter of my pentagon, which would then allow me to find the area. So after I solve this equation here, put the 1 there, and then I have a proportion where I can cross multiply. So I found out that x equaled the tangent of 36 times 7, and that comes out to be 5.09. So now I know the length of that little piece is 5.09. Now if I multiply that by 2, and then multiply by 5, I'll have my perimeter. And I'll have everything I need to find the area of my pentagon. So I'm going to do that right now. Put that in there. So the area of the pentagon is going to be 1/2 apothem, which in this case is 7, and then times the perimeter of the pentagon, which is going to be that 5.09 times 2. There's one of the side lengths of the pentagon, and then there's 5 of them, so multiply it by 5, and I will have it. When I put that all together, I'm going to end up with approximately 178.00. That's for one pentagon. Now I need to find the surface area of the other pentagon, which would be 178.00 as well. And now I need the area of the rectangles. So I'd have to take the base times the height. Well, I go back to my rectangles, and you can think of the base, well, that's going to be this 5.09 times 2, and then multiplied by 10 for the height. So I can go 5.09, multiplied it by 2 because that's the length of the base of it, and then multiply by 10 for the height. And here we're going to end up with 101.8. And then, if you remember, there are 5 of those rectangles, and they're all congruent. So I can go with 101.8, 101.8, 101.8, and 101.8. Now I need to add all of that together to get my grand total. So when I add that all together, I end up with a grand total of 865, and my label on that would be what? Square centimeters. Now remember, that is just the surface area of the small one. Ultimately, this problem, yes, I know a little lengthy, but it also wants the surface area of the larger prism, as it states right here. So now I can use this scale factor of 4/7 and my surface area ratio to help me find the surface area of the larger prism. So I'm going to come down here. I have a scale factor of 4/7. My surface area ratio is going to be 865 to x, because I don't know the surface area of the larger one. Now remember, this is a scale factor, or the length ratio. This is a surface area ratio. So what ultimately I need to do is I need to turn my length ratio into a surface area. So to do that, I can square it. Now it's no longer a length ratio, it's now a surface area ratio. And now these two ratios will be equal. So I can cross multiply to help me solve this. When I go this way, I end up with 42,385. And when I cross multiply this way, I end up with 16x. So I finish by dividing both sides by 16 and find out that x, or the surface area of my larger prism, is going to be 2,649.06 square centimeters approximately. Now my last problem, I'm going to use the exact same regular pentagonal prisms, but this time I want to find the volume of the larger prism. So first we're going to have to find the volume of the smaller prism. Well, remember, to find the volume of a prism, volume is going to equal area of the base times height. Well, being the last problem, we already calculated the area of the base in the regular pentagon right here. I can use that 178 as the area of my base. So I have 178, and it tells me that the height of the prism is 10 centimeters. So I now have the volume of the smaller prism is going to be 1,780 cubic centimeters. And remember, we already have the scale factor ratio of 4 to 7. So what I can do now is I can write that ratio, 4 to 7. I can write a volume ratio of 1,780 over x, because I don't know the volume of the larger one. And remember, this is a length ratio or a scale factor ratio. This is the volume. So we just need to turn this length ratio into a volume ratio. And the reason I want to do it that way is because I have the x right there, and I want to leave this one alone. So let's turn this into a volume ratio. Take that length ratio, if we cube it, no longer length, and now it's volume. Now we have two ratios that are equal, and I can solve my proportion. So when I cross multiply this way, I get a rather large number, 610,540 equal to, and when we cross multiply this way, we end up with 64x. Continue on, divide both sides by 64, and we're going to find out that we have an answer of x equal to 9,539.69, approximately, depending on where you have all the decimals. And being the label was centimeters, we're going to have cubic centimeters. So using our properties of ratios, we can find the volume of similar prisms, and we don't even have to know the dimensions of that prism. So keep all this in mind, being able to set up your ratio, and then being able to, sometimes you have to cube it to get it to be volume, or maybe you have to go back the other way. Maybe you got to take the cube root of this one to make it the side length. But it's all going to depend on which ratios you're working with. And that's going to conclude my examples dealing with similar solids.